All right, I promise this one isn't going to become political, but it is looking at a little bit at politics. So the Florida recount in 2000, the 2000 election gave George W. Bush 2,912,790 votes, and Al Gore got 2,912,253 votes. It was historically a very, very close election. You can see it was just 537 votes apart. So, it definitely elicited a lot of all sorts of misspellings in here. It elicited all sorts of recounts and stuff like that. So, in any case, that's history. But what we're going to do here is say, what is the likelihood of the vote of two candidates being within 600 votes, because you can see these are only 537 votes apart. What's the probability that you end up getting the votes being within 600 votes if voters have an equal probability of choosing each candidate? So you go to the polls and you flip a coin as far as which candidate you vote for. So we're saying here, we're taking the entire population of everyone that voted either for George W. Bush or for Al Gore. That gives us a population of 5,825,043 people. And we're saying the probability is 0.5. And we're going to say that X should be within 300 of the mean. The reason I'm going from, I said here, we're talking about the votes being within 600 votes of each other, and we're changing that to being just 300 within the mean, is because anyone, we're assuming that each of these people, all of these people are going to either vote for one person or the other. So if one candidate loses a vote, it kind of goes the other direction. So if you lose one vote, it actually kind of splits the difference there. It changes the difference between the two people by 2. So in any case, you can kind of see that if there were 300 people that went one way, so if we kind of started out in the middle, 300 people went one way, then they would have to be pulling from the other candidate. I guess I don't know how to draw that, but whatever. 300 people from one candidate switched to the other candidate, then the difference between the two of them would be 600 people, just because this person not only lost one, but their opponent picked up a vote. So that's why this whole, we're talking about this being within 300 votes of the mean. So first off, we're going to do this using binomial CDF. Again, doing the exact value here. Let's see, binomial CDF. Each trial, a trial is a particular vote, so just one vote. And a success here, I'm not going to declare either of those a success because that's just too controversial. I'm going to just say our candidate. They vote for our candidate, whoever our candidate is. Fill in your own political party if it makes you happier. All right, so we need to, since this is binomial, we're going to, I guess we already have n, p, and x here. So n is that number right there, p is right there, and x, well, x should be between two values. We want it to be within 300 of the mean. So that means that this will end up being less than or equal to 5,825. Actually, let me just do this. 5,825,043 minus 300 is 5,824,743. 5,824,743 is less than or equal to this. And then that number plus 300 to get 300 more than the mean, we get 5,825,343. So we're looking for x. We're looking for a binomial distribution with x being between these two values. So again, kind of thinking about how this, all the different possible values for the number of successes, 5,825,043. We could go anywhere from, let's see, 5,825. That's not right. That's not our mean. That's our total number of people. I'm going to take that number divided by 2 and then add 300 to get 300 votes more than the mean. which will end up being 2912821.5, and that number minus 300 is 2912221.5. Now, that 0.5, of course, is not possible. This is a binomial distribution, so we have an exact number of votes. It's not a continuous distribution. So this is going to be all the way up to 2912821. That's the, I'm dropping the 0.5 because that 0.5 is not possible. And then the lower bound here is 2912221. Actually 222. I'm bumping up slightly because I want to be between these values, and 221 is less than 221.5. So I have to bump it up slightly to get 2222. So we're looking for the probability of being between those values. So I'm going to do the binomial CDF with x equals this number, and subtract off the binomial CDF with x being 1 less than this number. Okay, let's try this on the calculator. Binomial CDF, NPX. We need to do n first. 5825043.5 and 2912821. When we go to calculate that one, even without even starting on the next one, you can see we have that domain error. This is too big for this calculator to be able to deal with. We can't do binomial distributions with numbers over 1 million. I'm not actually sure where the cutoff is there, but this is not possible on this calculator. This is a TI-83 Plus. Your calculator might have been able to do this one, and I'm sure if it did, it probably took a little while. So instead, what we have to use the normal approximation. We can't do this one we can't find the exact value using binomial CDF. So just like the previous example, we first need to figure out our mean, which is n times p. That was, I guess it's not on here anymore. 5825043 times 0.5. 2912521.5. We need our standard deviation, which is, so this was n times p. This one is the square root of n times p times 1 minus p. So let's figure out what that is. Square root of, I'm going to cheat a little bit. This right here is already n times p. Then I'll do my times 1 minus p. So we get that, which is 1206.75. 1206.756. That's our standard deviation. Okay, so now what we're looking for is the probability of being within 300 votes of the mean. This is our mean. We want within 300 votes of the mean. I'm not exactly sure how to draw that. Let's just do some lines on there. So our upper bound, we actually already figured out what these numbers are. That's why I didn't mind doing it up there. This is 2912821. And then down here we have 2912222. Let's see. That would be actually, if we were talking about the binomial CDF, I rounded those off, but I would actually need to bump it over slightly, half a value either way. Turns out we actually end up getting back to these numbers, although that's kind of just by coincidence, I think. So we end up getting the 0.5 there and the 1.5 here. Again, doing that bumping out slightly so we can make sure that we have a full area. we end up increasing this one by 0.5 and decreasing that one by 0.5 so that we have the full area there. All right, so now let's go ahead and try doing that on the calculator. Normal CDF. Our left bound is 2912221.5. Let me verify that. 2912221.5, yeah. My right bound is 2912821.5. Big numbers. Let's see. My mean is 2912521.5, and my standard deviation is 1206.756. And you can see there's approximately a just under 20% chance. 0.1963. Which, I don't know if that's satisfying or not. But that does kind of show, even if they're, I mean, that's not exactly realistic here. They don't show up to the polls and choose a candidate at random. Most people are decided ahead of time before they go and vote, I imagine. I would hope so, at least. People have done their research and have their opinions made before they go and vote. But you can see, if you do have a county, or I guess this is Florida, this is not just a county. If you do have a state where your electorate is evenly split as this, it's actually not all that unlikely that you do end up getting a really close vote. Again, that's probably, there's other factors here, whether or not, I'm not going to get into it. Yeah. Sorry, I'm intentionally trying to avoid the politics part of it. But yeah, so if we had a 50% chance of choosing either candidate, then we're talking about a 20% chance of being within 300, or within of the two votes being within 600 of each other.